Okay, well, I hope that the clouds stay thin or go away tonight. Tad and Mitchell are up on our roof deck, and they are running our telescopes tonight. So hopefully we'll get some nice shots of a few things out in our very cold November sky. But as we keep going, I do want to say that part of my welcome here is to say the museum here aims to advance our collective understanding of both the Earth and the sky. And I would like to acknowledge the Bell Museum sits on traditional and treaty lands of the Dakota people. I would also like to acknowledge the Ojibwe peoples, traditional keepers of the lands to our north. Ojibwe and Dakota knowledge systems are crucial ways of knowing the place we now call Minnesota. And we here at the Bell honor that knowledge, the values embedded in it, and the people who keep it. Tonight, we hope that you have many questions or you think of many questions along the evening. And questions are our favorite part of the night. Please do use the Q&A box to ask us those questions throughout the night, and we'll get to as many as we can. We also have some staff behind the scenes that if we can't get to all the questions live, they'll be typing out answers throughout the evening as well. But we'll try to get to everybody's question by the end of our time together this evening. And this event is being captioned. If you find those captions distracting or not useful to you, you can hide them by clicking on the Live CC button on your Zoom screen. There's also a link that we'll push out to you guys in the chat for an additional way for those captions if that is easier for you. But tonight, we're here to talk about the night sky, what we can see here from the Bell Museum in St. Paul, Minnesota. But we're also going to talk about the Artemis 1 mission that is going to come up in hopefully the next several months. So that's kind of our theme for tonight. But before we jump into it, Tad, do you want to introduce yourself up there on the roof deck?
Yeah. Hi, everyone. Hope you're all doing okay. We're myself and Mitchell are out on our deck, our observation deck, on a kind of chilly evening. I've only got like 3 layers on, so I guess we're not quite in the midst of Minnesota winter yet. But we are gonna fight the wind tonight, and fingers crossed, no clouds though. We do have a view. I'll quickly share my screen, Sarah, if you don't mind.
Go for it.
Yeah. I will quickly share our first view that we've got here. Our focus is still a little fuzzy, but we are looking first right here at Saturn. So that little, not quite so little, but that little fuzzy blob there on your screens is only about 1 billion miles away, and that is our ringed giant planet in our solar system. And I think, Sarah, you'll be talking about somewhere to see stuff in the night sky, is that right?
Yes.
Okay, well, I'll steer your thunder a little bit and just say if you are on a phone, or you can take your laptop outside, wherever you're using to view this. Saturn is kind of hard to see. We're only going to have it for a little while here, but it's visible to the southwest, and it's just a little speck of light. There's a little bit of haze over it, and if you see the motion there, there's a lot of wind as well. But you can also take a look outside yourself to see what we're going to see tonight in the night sky. So I hope you all are outside looking in the night sky as well. All right, I'll go back to you, Sarah, and we'll get some other things on deck as well to see.
Yes, no, it's wonderful to kick off the night with a planet. Galileo, when he first saw Saturn with his very early telescope, called it a planet with ears because he wasn't quite sure what those things sticking off the sides were. But as you can tell, and maybe we'll swing back to it throughout the night, now that we know that there are rings, we can actually tell the gaps around the planet itself and the rings. So planet with ears makes me smile each time. For the first time somebody saw it and didn't know what was going on there. But let's jump into what can we see and where is it going to be? So I'm going to steal the screen back here, Tad. Okay, so hopefully you can all see my screen now. And this star map here is good for through November all the way through the end of our calendar.
Heads up, I think we're seeing your presenter view there. We've got next slide as well showing.
Okay.
We're just giving everything away right at the beginning here.
Let's try this again. Is that any better?
That looks better to me, yeah.
Okay. So this star map here is good for this month and through next month. And you'll also notice that there's some times here because as the Earth rotates as it's orbiting around the sun. And the sun does set earlier as we get through to the winter solstice. The sky map isn't going to be the same at the same time for very long. And you can always download our star maps there. We do put them on our website. So here is the link on the slide, but we'll also throw that into the chat. So let's take a closer look and kind of see where things are tonight and for the rest of the calendar year here. If we look at the outer edges of our star map, that is the horizon. And we have our star map in the circular format because if you stood in one spot and you kind of did a circle all around, your view would trace out the horizon here would be very circular. At the very point, the very middle of our map, though, that's going to be the point directly above you. That is called the zenith. And so if something in our map appears closer to the outer edges, it's going to be closer to the horizon. But if it's closer to the center of our map, we know to look more straight above us. Some things to point out that you can go out tonight and see. We'll start with Saturn, which Tad has already shown us through the telescope. That is down in the southwest corner of our skies. You'll see it's not quite, it's a little bit closer to the horizon here. And not too far away, though, is also Jupiter. These are two of our gas giant planets. Jupiter, when you look out in the sky tonight, will be the brighter of these two lights. And without a telescope or binoculars, they will kind of just look like little bright pinpoints, but they will appear brighter than some of the neighboring stars. So definitely look for Saturn and Jupiter throughout the rest of the calendar year. They will kind of be slowly moving closer and closer to the southwest. By the end of the calendar year, they will be kind of setting closer enough to the sun. So we're not going to have them too far past the new year. But we also have the full moon, or almost full moon tonight. I'm hoping somebody maybe was up very, very early this morning and caught the almost total, but still partial lunar eclipse. Did anybody happen to be up around between 1 and like 2:30, 3 o'clock last night or early this morning? And did anybody see that lunar eclipse happen? Tad, did I hear that you might have been up early this morning?
All right, yeah, you read my mind there. We're going to actually get a screen share going here in just a second of our moon. We have our moon through another telescope. But yes, I was up very, very early this morning. Got up around 3 o'clock or so to see our moon being eclipsed. It was a 97-ish% eclipse tonight, last night or this morning, whatever it was. It was a great morning. I have to say my expectations were, well, I was expecting to get up at 3 o'clock in the morning. So that's what my expectations were. And the sky, though, really made it worth it. The moon itself was really beautiful to see. It was it actually reminded me, maybe because we just came out of the season, the holiday here, it reminded me actually a lot of a pumpkin in the sky. And Sarah, we just need to make sure that Mitchell can share his screen, actually. It reminded me a lot of a pumpkin in the sky. It had that orange glow to it. As that light from the sun was bouncing off it back to us. Not quite as deep red as some people. I don't know who's listening here. Who you might have seen a year or so ago. We had that blood moon lunar eclipse. Very dramatic. Great night for that here at the bow. But then also, I went out and there was the moon. Of course, that was the star of the show. No pun intended. But the rest of the night sky was actually really great too. The wind had died down, the clouds were gone. The moon was right near the Pleiades, near M45. We also had Orion nicely visible as well, further to the south. And actually, while we're getting that screen share set up, I think there's some issue with that other screen share. I'll go ahead and share a not great photo. I want to start with that actually. But I got a new phone a little while ago, so I was trying out the night mode on it, and I was trying out a few different photos of the night sky there. So there was the partially eclipsed moon. There's the Pleiades above it to the, I don't know why I'm doing that. Here we go. The Pleiades above it to the right. And we're seeing a little bit, some other scattered stars here as well. Yeah, it was a really nice morning. I'll actually just flip through a bit here. See a little bit. I want to see if there we go. I try to get this all in one shot. I thought it was great. There was Orion right there again to the south. And And then, we see him a little bit later in the year in the early evening. So it was really nice to see him this time of year, even if I had to get up early. But his belt is here. And then down from it, I also got in this field of view right over here, the dog star Sirius, our brightest star in our night sky. We can see a little bit of the horns of Taurus over here. Again, the Pleiades are here. This long dark streak along the bottom, this is what's known in astronomy as a power line. It's a very rarely seen transient event in the night sky. You might not be familiar with that one. And then, of course, we have on the right here those things that always get in the way. I forget what we call those. Yeah, it was a really good morning. I ended spending good 15, 20 minutes out there. It was very cold. So that was about as much time as I wanted to spend at that time in the morning. But yeah, it was really great. I was very impressed by it. So I'm looking forward to the next one. I need to look up when exactly that one's happening. But I'm looking forward to the next one as well.
Okay. We might have solved it. Can you try that screen share of the moon if you still have it? There we go.
Excellent. So, so we've got our moon here. Excellent. So we were seeing this eclipse in the morning. We'll maybe move the scope around so we get a little more of Tycho in view there. And over here. Just changing the settings.
Well, as you're adjusting things, I can kind of see a little bit is that I'm getting Tycho crater and Copernicus crater mixed up, but I'm pretty sure it's Tycho crater down in the lower part of the image. You see how that beautiful ejecta comes spewing out from that bright crater down towards the southern hemisphere of the moon.
Yeah, that is on my. I can never remember many craters on the moon because there's tens of thousands of them, but Tycho is by far one of my favorites. Incredibly young crater, somewhere under 100 million years old. So it's kind of crazy to think that just in fairly recent time, there were and there still are these massive rocks orbiting around the sun and occasionally just impacting places rather dramatically. I mean, we know that here on the Earth as well, but the moon is a very clear reminder of what's going on above our heads.
Well, this shot actually reminds me, and talking about the lunar eclipse last night, reminds me of a previous lunar eclipse event we had here at the Bell Museum. And it kind of ties into Joseph's question of how long have we been doing this? Now, Tad and I will have different answers personally, how long we've been running telescopes.
Very
But
long.
We've been hosting.
Is the answer.
Sorry, what was that?
A very long time. I just feel like is the answer.
Yeah, we both love telescopes. It's a passion of ours. But here at the Bell Museum, we've been hosting star parties for probably since 2016, since before we opened our brand new facility, which opened here on the St. Paul campus back in 2018. But it was the January of 2019 is when we had a total lunar eclipse that we saw here. We had a in-person star party at the Bell Museum. And Tad, actually, somebody was able to catch an impact on the moon during that lunar eclipse back in January of 2019. So just thinking of the eclipse that we had last night and then these craters, which are actually happening all the time, remind me of that really kind of cool night, very cold night outside in Minnesota winter.
Yeah, someone really needs to schedule these eclipses for like a more convenient time. 3 o'clock in the morning in June, I'd be down with that. I'd appreciate a warm eclipse in the sky. We also have all the great meteor showers are also all in the winter too. But the Geminids and I guess the Leonids is more spring, right? So.
Yep. But we will be talking about the Geminids and meteor showers in next month. So that's a little teaser to come back in next month for our virtual star party.
I totally did that on purpose.
Yep. A fun fact that I have not vetted myself, but I did hear this past week, and Tad, maybe you've heard about this, talking about the moon and the craters here, that a chunk of the moon recently broke off or something hit the moon and a chunk of it went flying off. And so there's like this little mini chunk out there orbiting the Earth with our own moon. Have you heard about that?
I have not. It wouldn't super surprise me. I mean, there's still some big impactors left in the solar system, but yeah, that's interesting. I'm gonna have to look that one up. But yeah, I'm gonna do that here in a minute. Yeah, it wouldn't surprise me. But did we see that happen? Is that what someone was saying? We saw that happen?
I did not get that clarity, but I just heard that there was a small chunk of them that broke off that we were now tracking. So I have not vetted that myself, but that is a through the grapevine piece of information I did hear this week. So hoping that it's not false, but it'd be cool.
Yeah, I know we found those mini moons before. I mean, we found asteroids under captured asteroids essentially. I wonder if they're able to like chart its orbit and sort of determine that it came back. They found an orbit that closely aligned with the moon, so they think maybe it came from it that way.
That very well could be how we found it. Yep. Okay, but you showed us. I'm going to steal a screen back here. Gorgeous picture of the moon, and hopefully we'll come back to it later in the evening. But I'm going to move on a little bit here because, Tad, you mentioned Orion and Taurus, and those are some of the wonderful things that are coming up this winter. And we can kind of see them just a little bit here in our chat or in our star map. So again, this star map has the dates and times for it. So this is really early, about 7 o'clock right now. So if you were to wait a little bit longer, over in the east of our star map that's when you're going to start to see Orion rise. But Tad did point out that V of stars that marks Taurus, the bull's head. And we can see that over here on our screen has this big V over on the eastern part, the bright star Aldebaran. That is the eye of Taurus, the bull. So definitely take a look for this V of stars here, just starting at 7 o'clock this evening, and it'll get slightly earlier every night through the rest of winter. But another great thing to see in Taurus is not too far away. This little blue square is the Pleiades, also known as the Seven Sisters, or in Japanese, Subaru. So if you drive a Subaru car, their logo and all those stars are actually this cluster of stars in our sky coming up this winter. And that's actually one of my favorite things to see in our winter sky is this cluster of stars. You can actually see it with your eye. You do not need binoculars. You do not need a telescope. It'll look like a really tight cluster of stars. Some people even think it looks like a mini dipper. But that's actually the Pleiades, a great open star cluster in our winter skies. But other few things to look at here, if you do have a star map or choose to download it from our website or pick up a printed version if you happen to come visit the museum, is if we look kind of in the middle of our map here, we have the square that is the body of Pegasus. This here is known as the fall square. And they're four fairly bright stars. But from that, you can find 2 other deep space objects. So if we take the 4 squares, the fall triangle, and kind of go up to the horse's head, that kind of arcs down towards the south here. And not too far off is M15. That is a globular cluster of stars. So while the Pleiades over in Taurus in the east will be kind of an open cluster, there'll be a couple hundred stars there kind of spaced out. N15 is a globular cluster, which is a very tightly packed set of stars. And there's going to be thousands of stars in that one kind of denser object. So that's another great thing to look at in our sky tonight. But if you go take that fall square back of Pegasus and go off to the other direction, kind of up to the northeast, we'll hit M31, the Andromeda Galaxy. Now, you will need a nice dark sky to see this, because here in St. Paul with the light pollution on, we really can't see it too well without our telescopes and our cameras. But if you get away from some of these city lights, you can see it. It looks like a little smudge in our sky. And this is actually the farthest object that the human eye can see without using binoculars or telescopes. And M31, the Andromeda Galaxy here, is about 2.5 million light years away. So that's a pretty far distance. And it's really cool to see when you do get a nice sky to see it nice and clear. So let's keep going because this is a little bit of what we can see in the sky, and Tad will kind of jump in as we go this evening with what the clouds allow us to see from our own roof deck here at the Bell Museum. But we can talk about Artemis. Now, Artemis is a mission that is coming up here. The Artemis 1 is going to be launching, and we'll get a little bit more into that. But the reason why this next set of missions back to the moon, when humans finally go back to the moon the first time in about 50 years or so, is because Artemis, coming back from Greek mythology, is actually the twin sister of Apollo. So those very first moon landings, the Apollo missions, this is Apollo's sister, Artemis. And what this new initiative is going to do, this new era of space exploration, beginning with sending humans back to the moon and then further on past that, is we'll continue to be discovering life-saving and earth-changing sciences and technologies along our way. If you think about it, our phones would not exist if it were not for the Apollo missions. Because a lot of the technology that the Apollo missions had to develop to get humans to the moon in the first place, then later went into inspire the technology we use today. In fact, our phones here have more technology in them than the entire Apollo mission did to get somebody to the moon. So they did not have as much technology as we carry in our back pockets on a daily basis. And a part of why this is so exciting here is also because through this effort of getting humans back to the moon, our Astronaut Core, the group of astronauts who are active and training for going into space right now, is getting so much broader and more diverse and more inclusive than the Apollo era. Back during the Apollo missions, in order to be an astronaut, you had to be a white man in his 30s. That was a very narrow range of who was allowed to be an astronaut. And most of the time they came from military test pilots. But as we are recognizing some changes that need to be made in our society and just how everybody has something to bring to the table, the Astronaut Corps is becoming wider and more diverse and inclusive. And there's so many great people out there that part of the Artemis missions is to send those great people to the moon and to show that space flight is going to be for everybody. It's not just going to be limited to astronauts in the future. We're hoping for commercial crews, and maybe right now what is still in the realm of science fiction, where people can just go take vacations to other planets, one day that might actually be a reality. And the first step is to make space travel more inclusive and a wider range of people being able to go, whether it be in spacesuit design, space craft design, because that as well is being widened of who can go into a spacecraft. There are height requirements because it can't be too tall, or else you're not going to fit in the tiny spaces that are the crew capsules. So what is going to happen here on this Artemis 1 mission? Because before we can send humans, and that's a later Artemis mission, this our first Artemis mission has a few priorities. One is it's going to demonstrate the heat shield. So the part of this mission that the astronauts will be in is called the Orion spacecraft. And that has to demonstrate it can survive re-entry. And this heat shield is going to have to withstand temperatures above 4,000 degrees Fahrenheit. To give you kind of a reference point, I think the melting point of titanium, I believe, is around 3,000 degrees. And so we're well over the melting point of a lot of our metals. Really kind of far comparison is the surface of the sun is 10,000 degrees Fahrenheit. So this heat shield is going to have to withstand temperatures of almost half the temperature of the surface of the sun. And so that's going to be a really important test for this mission, Artemis 1, to pass before we put people in the Orion space capsule. It's also going to test the operating systems when it's in flight in the space and far distant lunar orbits. So we want to make sure all the systems are working. And another thing we have to do is once they do land back here on Earth, we have to make sure we can go get them out of the ocean and practice that retrieval process here. And so Artemis 1 is an uncrewed mission because we're going to test all these capabilities before we send humans into that capsule for the Artemis 2 mission. So if we keep going, the launch windows, when is this going to launch? Because not too long ago, we thought Artemis 1 was actually going to launch this month. But as they're preparing the rockets and as they're getting things and all these components stacked together, the launch window is actually going to be pushed until next year. We're hoping as early as February 12th of 22. But depending on the conditions and making sure we have the right launch windows, it could be anywhere every 2 weeks. So about once a month, there'll be a 2-week window where the Artemis mission could launch to make its trip beyond the moon, or just beyond the moon, but still further than any human has ever been. So that's when we can expect Artemis 1 here to launch. Again, hoping by kind of late winter, early spring kind of time frame, or it'll be exciting. It's a technology demonstration. But what is it going to do? Artemis is going to be launching using the Space Launch System, the SLS rocket. So that is, if you look in the upper left part of our screen, that is that orange rocket there. So it's going to orbit the Earth as then it detaches. It's going to then go following our green path here. It's actually going to go further out beyond the moon. So it'll be actually travel further into space than a human has ever been before. It'll do a loop around, then orbit around the moon before it does come back to Earth. And this whole duration of this first test flight is going to be roughly a month, give or take about a week or so. So let's go see a little bit more about what we can expect from this mission.
3, 2, 1, 0. Mission liftoff.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust, provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program, and there are companies all across our country that have a part in it, so there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon. Then, Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the service module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway, land on the surface of the moon.
We are there for, weeks, months on end. And there, we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies. The moon will lead the way to Mars, and we should be there within the next couple of decades.
So that video was from NASA, kind of celebrating and kind of promoting what's going to happen here on Artemis 1, because it is that first step to getting humans back into space. And we love questions. So if you have questions, please put them in the Q&A box. They are our favorite part of the night. One of those questions I do see is, do you think we're alone in the universe? Personally, I do not. We're talking about how humans can venture to other places, other bodies here within our own solar system. But if we look up the sky, there are so many stars, and each one of those stars on average has at least one planet. The odds, I think, just sheer mathematical odds are against us that we are the only ones out there. So maybe someone somewhere else is trying to this interplanetary space travel, just like we're attempting here with Artemis 1 and the future of going to Mars. So the Orion rocket here, that is what they're traveling in.
Can I interrupt, Sarah?
Absolutely, go for it.
Well, I thought that alien life, I thought that was a great sort of segue to what we've got here. We'll go. So if you can, you'll figure it out. I figured that was a great reason to interrupt with a view of Jupiter. And it's 4 moons. So automatically right here, already 4 times is better than the Earth. Although it's also got another 75 moons, so it is 79 times better than the Earth, believe it or not. But what we're looking at here in the very center, we'll zoom in a little bit here. That very bright point is Jupiter. I'll come back to that in just a second. And no, that was good. No, it was this much. We're zooming the wrong way there. Those other bright points of light we can see around it, though. A lot of wind up here. Over here, down there, and then there's two right there. These are the 4 Galilean moons. And I am trying to figure out which ones are which. My app that I usually use seems a little off right now on what we're looking at. I'm hazarding a guess that this one down there is Callisto. And then I'm going to hazard another guess that we might be looking at Europa up over here. I'm going to have to double check all this. But Europa in particular is a moon where we have found evidence of liquid water. We're pretty sure there's an ocean of water underneath its icy surface. And of course, if we've got water there and we've got heat, of course, keeping that water warm, then of course, everyone knows we've got space whales. All right, I just want to pause for all the laughter there. I know I can't hear it, but I know it's on the other side. Okay, maybe not space whales. Sarah, I can see you laughing, thank you. Maybe though, maybe not whales, maybe not like that complex life, but maybe basic bacteria, maybe something. It seems like a good place to look at the very least. And even other these moons like Io is the most volcanically active object in our solar system. If you look at pictures of it, it is covered in volcanoes that spew out sulfur that give it this red and orange color. Could compare it to our own moon this morning, in fact. And even places like that they could be places maybe we could think about looking because they might have some form of life like extremophiles that could survive around volcanic vents. The universe is a weird and wild place. So there's lots of places to look for life. Depending on your feelings about it, Jupiter may not be one of those places though. Let's take a closer look at the gas giant itself. Really drop down our exposure here. We've got a lot, you can see all the wind going on there. So I think maybe we'll go with this view. We're a little out of focus, we're a little fuzzy, but we're also dealing with the wind here. Hopefully maybe you can see a little bit of the stripes there in Jupiter's atmosphere. So when we're looking at Jupiter, one of our gas giant planets, we've got winds rising and falling in these massive convective cells, and then they're drawn around by Jupiter itself, or they're drawn around rather as Jupiter spins, and that causes these different kind of like jet streams in the atmosphere of the planet. It's an incredible world. As Sarah started off saying, it's up in our night sky. It's the brightest point of light to the southwest. I'm not really seeing any stars around it. So really, if you're looking to the southwest and you go outside, you're looking to the southwest, you see a bright point of light. It's not moving. It's not twinkling. It's not blinking and hovering and about to abduct you. Then you're probably looking at Jupiter there. I see one question from Izzy, which I'll just take a chance to answer, asking which planet is your favorite? My favorite planet, Izzy, is in fact the best planet in the solar system, which is the planet Saturn. Saturn, the best planet, and by far my favorite. It is kind of behind some haze right now, so we might not get back to it soon. I was going to try for some other objects before we get back to Saturn. All right, anyway, that's a little bit about Jupiter there, and it's just 4 of its moons. Again, got 75 along with those 4 Galilean moons that we'll bring back into view quickly here before Sarah, I stop interrupting and let you back into things.
Okay, well, it's a great view of Jupiter because it's definitely worth looking at. And there might be places for life, like you mentioned, just here in our own solar system. Izzy, to kind of answer your question myself, I actually really like the planet Uranus. The reason why I like Uranus, and unfortunately it's not visible in our sky by the naked eye, it's just too far away, is because it was the very first planet ever discovered. And when he first discovered it, it was named George. And so I like that Uranus is just so different from all the other planets, and it has this really fun history to it. So that's why I like that planet. But Saturn is wonderful to look at in our night sky. You can see it as a point of light just off to the west of Jupiter. But if you do have binoculars, or how we opened tonight with seeing that planet with a telescope, seeing those rings with your own eyes is definitely something that you shouldn't miss if you ever get an opportunity to do it. So I'm really glad we saw that planet at the very beginning of our evening, just in case the clouds prevent us from going back to it tonight. I see a lot of questions about Mars, which is really exciting because we're talking about Artemis 1 here, but it's all building up to Mars. So we're going to build there tonight as well. So one of the questions also was about sending animals into space. Well, are they going on the Artemis missions? But they might already be out there in space here. So as we keep enjoying the view of Jupiter, the International Space Station actually has things like fruit flies. They've brought up different insects up there to see how they behave in space. I do believe they've even brought up mice onto the International Space Station as well, just to see how different organisms behave in the weightless environment or the microgravity environment. But also they've brought up plants, both to grow, so hoping that humans can have a nutritious source of fresh food while they're in space. But then also to see if their nutrients are any different. I know some companies have sent flowers or a rose up into space to see if it'll bloom and if it'll smell any different in space, the way it kind of, the flower develops in that microgravity environment. So yes, animals have been sent into space. They were definitely part of the early space flights leading up to Mercury and the Apollo missions. And then we do continue to send smaller animals into space as well. Not quite ready yet for, let's say, Larry Cat or anything like that. But one day, maybe our pets will be able to join us in space. Okay, Tad, I'm going to take the screen back if that's all right with you.
Yeah, that sounds good. I'm going to see if there's some, I'm going to be really ambitious. M15 is up. You mentioned it earlier. It's a beautiful globular. I'm going to see if we can get that. Let me know too. We still got our moon too. So folks, we can go back to our moon as well. I'd love to show off, but fingers crossed out here on the very cold Ruth and John Huss observation. Back to you, sir.
Yeah. So we're coming back here to the Orion Capsule. So the Orion Capsule is where the humans will be when they go into space, going to the moon and beyond. And it's actually a fairly small space. It's not that big. If you've ever been to the Bell Museum and visited our planetarium, one of those entry doors between the outer part of the museum and getting into the planetarium, it's only about that big. I'll say it's kind of like a large shower stall or bathroom, single-use bathroom. It's really not that big, so it's not something you'd want to spend too long in the Orion capsule itself. But the Orion capsule will be attached to the rocket and some other components that then once they're in space, the astronauts won't have to be solely in the Orion capsule. To get to space, on top of the rocket here will be our launch abort system. And so this was in the video briefly, but we have the Orion crew module here in the middle. And then, but housing it above it here off to the right side of our screen is our launch abort system. So should anything go wrong as the rocket is trying to leave the ground, this launch abort system is there to safely detach from the rest of the rocket and bring the astronauts back down to the ground safely. So we have the very important abort system kind of leading the rocket. But then on the left-hand side of our screen, we have the service module, which is actually being provided by the European Space Agency. So going to the moon and going beyond the moon, a lot of these space missions are no longer, and they're so big that no one organization can do it all by themselves. And so this truly is an international effort. And so this service module is going to be where some of the power and the oxygen, and so that is going to be supporting the launch as it gets into space, gets out of Earth orbit here. The whole thing will be launching on the Space Launch System. So here is kind of what we expect it to look like as it launches from Launch Pad B here in Florida. And this is the most powerful rocket that we have built to date. So many of you might think, remember back to or think of the Saturn V rocket that launched the Apollo missions into space. This rocket that will be launching the Artemis program is not quite as tall as the Saturn V, which we can see over on the far right of our screen. But this first version of the Space Launch System with Artemis 1 here happening in the next several months is this middle image here. So it's going to stand about 17 feet taller than the Statue of Liberty for this first configuration. And it can travel a huge payload, a very heavy payload, whether it's people, it could be supplies. Up in that top part of the capsule, this orange and these kind of two white parts of the rocket down here, that's all going to be helping it to get off of the Earth and getting into space quite quickly and getting that push. But up here at the very top, we have that abort system, and then the Orion capsule will be in kind of this upper part of our space launch stack, if you will. But it can also hold a lot of materials and a lot of payloads that aren't humans. And this first block, this first configuration could send the equivalent of 12 full-grown elephants into space. Now, it is really expensive to send very heavy things into space. And so when going to the moon and building an outpost there or going to Mars, we are making the best we can out of how we pack these spacecraft to be very smart about it and bring what we need, but not too much extra out here. To kind of give you if you look at the very kind of right off to the right side of the Statue of Liberty, you can see a person and a giraffe. So these rockets are ginormous. And one of the things about the Space Launch System is that it has multiple configurations. So as we start building outposts at the moon and start getting things sent even further out to Mars, we have the Orion Block 2 here, the second in from the right, that has an extra kind of compartment there, if you will. So it will stand very comparable to the Saturn V once we get into the future configurations of these Space Launch System rockets. One question that came in from Sammy is who will drive these rockets? So a lot of this will be done, at least in the launch, the countdown, will be done by ground crew. And so a lot of it's programmed in. But once they're in space, the travel to the moon will take several days. And that's why one of the astronauts will be kind of designated as the pilot should something not work in the kind of automated piloting system. So astronauts are being trained to operate the Orion spacecraft and the rest of the components that will be safely orbiting them and then eventually landing them back down on the lunar surface. But a lot of it is automated as well. A few more questions came in. Let's take a look at these. Maddie from the Girl Scouts is, how many days will we be in space? So I personally, unfortunately, will not be going to space. I would love to go to space, but I'm not part of the astronaut crew. But the astronauts who do go to space can spend sometimes about 6 months in the International Space Station, going to the moon here with the Artemis programs. Artemis 3 will be the first crewed mission to the moon to actually touch down on the surface. I believe that's about a month long in space. But when we eventually do get off to Mars, the trip to and from Mars can be the better part of almost 3 years. So depending on where you're going in space, that will determine how long you will be in space. And so I'd like to go to space maybe for a week or so, maybe take a vacation at the moon. I'm not quite sure I'm ready to sign up for a 3-year journey to Mars and back. Okay, let's see. So we're talking about going to Mars, and we'll keep getting to that. But will they send Legos to the moon, Oliver and Nigel? This rocket is kind of like a giant Lego set because we can stack it and configure it in many different ways. So if we take a look at this next slide, this is it actually in one of the components at down in Florida, and it's being stacked. So right here, these are the rockets, just a space launch system here. But then the Orion Capsule and the Abort system are being stacked on top of it. So we can see that process of kind of wheeling it in and then using gigantic cranes to go then put it on the far right image here of how that space launch system is being topped with the Orion and the Abort systems to complete the overall rocket here. Okay. But what are we going to do when we get to the moon? Why are we going back? Those are very valid questions many people have. By going back to the moon here, there's a lot of valuable science that we're going to be doing. One thing is that the moon is not protected by a thick atmosphere like Earth is, or a magnetic field like Earth has. And so on the moon, there can actually be a record of what the sun was like way back during the early parts of the solar system. And so they will actually be taking some core samples of the moon to see if there's what information is stored in those rock layers of how the sun was behaving back during the early solar system. We'll also keep studying some lunar science, kind of getting a better understanding of how we got the moon and the history of the moon itself. And that system, because the Earth-Moon system right now, our understanding is that the moon, or the rock we now know as the moon, used to come from the Earth, that something happened millions of years ago, billions of years ago even, where it broke a chunk of the Earth off that then reformed and became our moon. And so better understanding of why we have our moon, because it's the largest Earth-Moon comparison that we have based on any planet in our system. A lot of the other planets that have moons in our system, their moons are quite large, but they're very small compared to the planet itself. So the ratio of the size of the moon to the Earth is quite large. It's actually the largest one in our solar system. So understanding how we have the moon and how it got to be today is actually something that we're really still very interested in. But what are we going to do? How are we going to get this done? We are going to be putting things on the moon, so installing surface instruments. So that way, like back when the Apollo missions visited, they left mirrors on the surface of the moon where we still can bounce lasers off those mirrors to kind of measure that distance from the Earth to the moon, because it is changing every year. But we're going to go land in what's the south pole of the moon, because we've never been there. And by going to a different region of the moon, we know the side of the moon that's facing the Earth is different than the side of the moon that's not facing the Earth. And we do believe that there is water frozen into the permanently shadowed craters in the poles of the moon here. And so we can kind of see this in this time-lapse video of this is a south pole of the moon, where along the edges of our craters here, those shadows could be holding some frozen water. And we all know that water is important to us here on Earth, but why might we want to find it here on the moon? If we find enough of it, we could potentially harvest it for drinking, but then also for rocket fuel to get back to Earth or even further out into space. So hydrogen is actually a very useful rocket fuel. And so if there are resources on the moon that can help us as we explore space, we do want to see if we can utilize those. Also, by being on the south pole of the moon, it's not only a region we've never been to before, humans that is, but also we will have constant communication back to Earth. So if the mission were to land on the far side of the moon itself would block any communication back to Earth. So we want to be in a part where we can talk to our astronauts out here at the moon, which is about 250,000 miles away. So that's one of the reasons why we're choosing the south pole of the moon. The exact landing location has yet to be selected. Looks like a good question came in from Vern about, will any of the components of the Artemis be returned to Earth and reused? So the Orion spacecraft, I think they're trying to get that to be reusable, and potentially parts of the SLS. But one of the things that we're trying to do is to make the SLS, the rocket there, so it can be in many different configurations based on what the mission needs are, and we don't have to develop a brand new rocket every single time. Okay. This is always a great question from Alicia. How do the astronauts go to the bathroom in space? Well, it depends on where they are, because if they're in the process of being launched off the Earth or landing on Earth, they do have space diapers. Or if they're doing a moonwalk, or not a moonwalk, a spacewalk. Right now, the astronauts at the International Space Station, there are times when they're outside of the space station for 8 hours doing their work. And so they can't come back in, take off their suit, use the restroom, go back outside. They're outside for a solid 8 hours. And so they do have astronaut diapers. Oh, it looks like Tad has a wonderful view of the moon for us.
Oh yeah, I figured just if you're answering, I figured, we had that great picture of the moon, but I figured to bring back our live view of the moon right now. Unfortunately, everything else is covered, pretty much covered with clouds. So yeah, that's Minnesota. We still got some time here, of course. So we're gonna keep trying for some other objects, but that is our moon right here, at least while we've got some questions going on.
Okay, yeah, no, that's great because the south pole of the moon then will be kind of down at the bottom part of our image. So we have that nice bright crater, the Tycho crater there, in the kind of lower left part of our screen. But another question that came in is how many people will be going to the moon? So the Orion spacecraft can hold up to 4 people at a time. And so when we do send humans to the moon, back in hopefully the next 2 or 3 years, we'll have 2 people stay in a spacecraft that's in orbit around the moon, and then 2 of the other crew members will be going to land on the moon. So each mission will have up to 4 crew members each time. And the goal is once we get in this process and we establish some resources there, the goal is to send a new crew to the moon about 1 time every year. So that we'll be going to the moon a little bit more frequently than we have in the past 50 or so years. There's a question here. Tad, do you remember, the question is coming about how much of the moon is changing, the distance to the moon is changing each year. Is getting closer or further. Do you remember the number? Because I don't off the top of my head.
I think it's leaving us at a rate of about 2 centimeters a year, if I recall correctly. Slow. It'll be its own object in the solar system though, when it finally does leave our gravitational effects. So essentially it'll be another dwarf planet when it finally does get far enough away from the Earth that it is no longer orbiting around us primarily, so it no longer primarily feels our gravitational pull. I ran the calculation on that though once for the time scale, and it looks like that'll take about 50 billion years. There's a margin of error there, of course. And in about 5 billion years, the sun is going to turn into a red giant, expand, and engulf the Earth and the moon. So I'm not sure we'll ever get a chance to see the dwarf planet moon in our solar system, which is too bad. I was looking forward to it personally.
Oh.
But we actually know that this is happening because when the Apollo astronauts went to the moon, they were able to determine this from that point and since then by putting retro reflectors on the moon. And these are little, essentially, cubes of mirrors. When you...
Oh, we lost you. I think he was talking about those mirrors that the Apollo astronauts left on the surface of the moon.
Yeah.
And so,
did you already talk about that?
I mentioned it briefly, but if you have more detail on it, I'd love to hear about it.
Oh, well, I mean, I may just say the same thing. They're super cool. If you look up images of these, it's one of the easiest ways to it's a way at least to measure distance. You have these little cubes of mirrors and you shine a laser at it and the lasers bounce off the mirror back to the Earth, and you can measure how long that takes. And if you know the speed of light, and you can make some calculations for the movement of the Earth itself, then you get an idea of the distance to the moon, and then you can chart how its motion. It's a very cool thing, and we know that it does vary a lot already. It varies by the orbit, the distance between the Earth and the moon varies by up to about 10,000 miles, I think, at most, over the course of its monthly orbit. That's why sometimes we get an annular eclipse, for example, instead of a total solar eclipse, just depending on where the moon is, its distance away from us. Yeah, I think that's all I had to say about retroreflectors. I'm gonna try another look at the sky with one of our other telescopes here, but there's this haze. If anyone's looking outside, you've probably seen the same sort of haze over the southern sky. It's very frustrating. Oh, we can see
some clouds rolling across the moon here in your screen as well.
We'll take a quick picture of that. That's pretty cool. I always love that view.
Oh.
We'll save a couple pictures of that.
Okay, so a few more questions that came in of how long will the Artemis 1 mission be scheduled for? So Artemis 1, depending on when its exact launch date will be, will actually take between just under a month and just a little over a month. So the Artemis 1, which is uncrewed, will take a little over a month or ballpark. But then when we get people going to the moon, like to actually go land on the surface, those missions will be a little bit longer. And depending on what their missions are and what samples they need to collect. So the duration of these missions to and from the moon will depend on exactly what is the goal to be accomplished for each individual mission. But roughly about a month or so. It doesn't take a month to get out to the moon. I believe the Apollo astronauts took about 3 days to get out to the moon. And then they came back in another about 3 days, but they were gone for a total of up to about 9, I think. So we'll spend a little bit more time out at the moon, orbiting it, going down to the surface to get more of those samples, and hopefully build a lunar outpost is part of the long-term goals of returning to the moon. Now you may be asking, somebody here in the chat, or why haven't we gone to the moon since the Apollo missions anyways? There's many different reasons that you could probably think up, but part of it was that the inspiration or the reason we went to the moon, the big push to go to the moon, we were locked in a space race with the USSR at the time. And so there was a big kind of country to country battle of who could do it first and who could do it safer and better. While Russia or the USSR did a lot of the firsts, the NASA definitely had a better safety track record than the USSR did back during the original space race. But then we also shifted our priorities of looking for other, studying other things in deep space, because NASA does way more than just look and send people into space. We do a lot of deep space telescope exploration. NASA also does a lot of stuff that is impacting us here just on the ground and putting satellites into space to orbit the Earth and study things like climate change. And so NASA's not just about the astronauts and deep space travel here. So there was a pause to focus on other elements that we now know NASA has branches in many different fields these days. So we are looking forward to going back to the moon here, though, to continue to pick up where we left off, but also to continue to develop things that might not have been developed otherwise. So that's one of the great things about space exploration is a lot of what we have in our daily lives would not exist without it. Right now, for an example, is thermometers. So there is the thermometers that you just scan your forehead with. The infrared thermometers, that technology was first developed to measure the temperatures of distant stars. And so a lot of this stuff that we're developing for space exploration gets repurposed, and it's called spin-off technology, and it's actually helping us in the medical fields and in our daily lives. So that's another question I get asked a lot about. It's like, why are we spending so much time and effort and money to go into space or study outer space? It's because we have so many benefits from that space exploration, from that technology development in our daily lives. So it really does improve our lives here on Earth to study outer space as well. But let's go ahead and talk about what we do after we go Artemis 1, because after 1, there's probably going to be a 2. And so that is when we will send the crew into space. So Artemis 2 will be the first crewed mission back to the moon. So Artemis 1 is really going to test that heat shield and the operations in space, making sure we can go retrieve them from the ocean from their landing. But Artemis 2 here, that's the mission that we're going to put people in to go to the moon and orbit the moon. They will not yet land on the moon, though, here for Artemis 2, but it will be the first crewed mission to the moon in over 50 years. And so we can kind of see how astronauts are training for all this. We do have these sample Orion spacecraft here on the ground. And so they are training right now to work all these things. Astronauts actually have a say in, and past astronauts help design these spacecraft because they know how they need to move and what types of things they need to hit and buttons and driving it. So here you can see 2 astronauts kind of in the foreground of this image. But if you look down through the image, you can see the other 2 kind of below them. And so it almost looks like they're kind of stacked in bunk beds as we're looking down the Orion, the interior of the Orion spacecraft here. If you look over to the far left of this image, you do see that they do have windows. So they do get to enjoy the view of space as they are flying to the lunar outpost. And so you can see one of the other ground crew members. It looks like he's peeking in with the window from outside of the Orion capsule there. But it's really not that much space. But then after Artemis 2 goes to the moon, with humans and safely returns them, that is when Artemis 3 comes in. And this will be that crewed mission to land on the surface of the moon. This is when that first woman and the first person of color will actually step foot or go back to the moon here and step foot on it. And again, it's part of a growing diversity and astronaut class. And so the astronaut class that was selected here to be part of this Artemis generation, these are those astronauts. Astronauts get assigned to a mission about 2 to 3 years in advance. And so right now we're kind of targeting around roughly 2024 is when we're hoping to send Artemis 3 to the moon. And so we should know here in the next year or so when and who of these Artemis astronaut crew will be assigned to those missions to actually go back to the moon. But here they are. You might recognize some names that have been on the ISS and that are veteran astronauts. Some of them are part of a new crew that have yet to travel into space. So they're still training. So it'll be a good mix of geologists, of doctors, of pilots, of all backgrounds when we do finally send humans back to the moon here. But what are they going to do when we get to the moon? Because we want to get them there, but then we're also going to be building Gateway. And Gateway, we can see in this image here, we have the Orion spacecraft kind of flying up from the lower left. Part of it is to kind of establish a lunar outpost or a waypoint. So this is an artist's conception of what Gateway might be like. This kind of orbiting International Space Station type module here in lunar orbit, where it's from this Gateway spacecraft that people will go to the moon and then launch from the moon back up to Gateway. And so that'll be kind of the landing and launch intersection waypoint between travel from the Earth and beyond. Let's go take a look back at back and look at some of our questions that are still coming in. And again, we love questions. If you have any, please continue to add them to the Q&A box. Since the craters are, question coming in, since the craters on the moon are still being created, how much is it a risk is there for astronauts that will land there? So a lot of the things that are still impacting the moon are quite small. We are tracking asteroids and smaller objects in space that are above, I believe we can go pretty small. I don't know if we can go down to 1 centimeter that small, but there's a lower limit, and we're tracking as many of those particles in space as we can. So that way we know if they're going to be damaging to our spacecraft or potentially a risk to our humans when they're in space. So on the lunar surface, there may still be smaller bits or kind of those micrometeorites. And that is something that we have to prepare for to insulate our spacecraft from getting hit from them, but also making sure our spacesuits for the astronauts, that if they were to hit in a very small area that the human body is, that we are prepared to respond to that. Another great question about astronauts. What if an astronaut gets sick while inside the rocket? What do they do? Astronauts, they can throw up. They're humans. When they go in space, it's not an easy, smooth ride landing or launching off of the Earth. And so it probably has happened, in which case sometimes it's just in their helmets until they can take them off and clean it up. If astronauts get sick while they're on a long duration mission, though, they are all being trained in some medical responses. And so they do get some medical training as well, because they're not going to have like an ER or an urgent care or just your pharmacy to use. They will have, we do try to anticipate things that might happen to them. So that way there is some basic medical care up there, and that they're trained in doing things like ultrasounds if they need to ultrasound each other or draw blood. That's another thing that happens even on the International Space Station, is astronauts often will draw their blood and send it back to Earth for analysis. And so they are trained in some medical care. And for these deep space missions, one of those astronauts is likely going to be a medical doctor as well. So you don't just have to be a test pilot or an astronomer to be an astronaut. In fact, if you want to be an astronaut, you might want to be a geologist or a medical doctor, or you might still decide to be a test pilot. Okay, let's look at some of the other questions that are coming in. What craft will the astronauts be using when they come back to Earth? They'll be using the Orion spacecraft. And so that's why they tested it. That's why the Artemis 1 here is going to be testing if they can thrive. And they do believe that uncrewed Orion module will survive a re-entry into Earth. So that Orion crew module will be both their launch vehicle and their re-entry vehicle. Okay, more questions coming in. I love it. Thank you so much for asking. Do we think that NASA's safety protocols were better than the USSR's because of Apollo 1? Very possibly. And it also comes back down to, at the time, what the priorities and the goals were. And one of NASA's goals from the very start was always to return humans safely back to Earth. So that way we valued the safety of our astronauts. And so that was always something that is at the top of any mission that involves humans is their safety. How do they eat? A lot of their food is prepackaged, unless on the International Space Station they are growing lettuce and other vegetables for testing, but they do get a little bit for eating as well. But most of it's prepackaged, and I don't have one here. But it's vacuum sealed. What they'll do is they'll add a little bit of water to it to kind of rehydrate it, and then they can eat it kind of out of these little vacuum pack things while they're in space. So we do want to save as much room as we can by kind of shrink wrapping a lot of the food. And it's kind of fun. I don't know how many of you like spicy foods, but up in space, because the liquid in your body kind of redistributes, one of the things that astronauts have said is they like spicier foods in space than they do on the ground, because they lose some of the senses of taste as the fluids in their body redistribute. And so they need spicier foods just so they can pick up some of those flavors. So if you like spicy foods, you might be well on your way to having the palate of an astronaut. Okay, let's see here. We've been building up here to Mars, because all of this is to help us get to Mars. Mars is a much longer journey than going to the moon. So going to the moon will be, we're planning for it to take about a month for them to go to the moon and to the lunar surface and come back. But going to Mars, again, is going to be about the better part of a 3-year journey, just because it is that much farther away from the Earth that they're going to go. And once they go, they're on kind of a nonstop journey to finish the mission and then come back. But it is quite a long mission. And so we want to build in these kind of increments as we learn more about human space flight into deep space, into outer parts of Earth orbits or leaving Earth's orbit, and having these waypoints so we can potentially stash resources there, so they can go and have kind of a closer way to restock before they do make that full trip off to Mars. And some of the questions that have been coming in about Mars are, when do we think we're going to get astronauts to Mars? And we're hoping to get astronauts to Mars in the next decade or two. Artemis 3 is that first return to humans to the surface of the moon, but we're hoping to get to Mars either in the decade of 2030 or 2040 is when it's probably going to be most realistic, learning from these first Artemis missions. And then, yes, it does 2050 seem like a realistic estimate of getting humans to Mars. And yes, I think that is within that target range. It might be as early as 2030, but that might be pushing it. It's quite quick, but it might more realistically be 2040s and into the 2050s. Absolutely. So with that in mind, some of you, if you are in school right now, think of how old you will be in 2040 or 2050. You might be part of that astronaut crew to go to Mars, because I will not be wanting to go to Mars by the 2050s. But maybe you do, and you'll be of just the perfect age to be part of that astronaut crew. Other questions about getting to Mars and beyond is, are there going to be any new propulsion systems being developed to get away from rocket fuel? There are many different propulsion systems being thought of. I don't know of any of them that would be enough to launch off the Earth without rocket fuel, though. Because even, let's say, the light sail, which uses the sunlight to kind of to push it through space, even that needed to launch off in a rocket, because you do need to be going faster than the escape speed of the Earth's gravity, which I believe is 120, and Tad, please correct me if I'm wrong, 125,000 1,000 miles an hour, 1,000 miles a second. Now I'm forgetting the escape speed of Earth. I'll have to look it up and get back to you. But you do have to be going faster than the escape speed of Earth to actually leave Earth's gravitational pull. So I don't know how to do that without rocket fuel.
11 kilometers a second, right? 10, 11 kilometers? I'm going to get back to you something else.
Okay. Yeah, I can't do the conversion of kilometers into, non-SI units off the top of my head.
It's about half. So what, like 5-6 miles per second?
Okay, so quite fast. Okay, has there been thought of how our impact on the moon or other places we try to explore and how to leave little to no impact? There has been. And we've actually employed a lot of that when we've been studying Mars here with our rovers. That's why our rovers, when they're being built and developed here on the ground of Earth, they're built in clean rooms. And so we are trying to prevent any Earth microbes, if you will, from contaminating other planetary bodies. That's also why when Cassini ran out of fuel, was running low on fuel back in 2017, we purposely crashed Cassini into Saturn because we thought the likelihood of Saturn hosting life would be much lower than one of its moons to host life. We do want to return to the moon Titan around Saturn to explore if things could be living in that moon or on that moon. And so to protect anything that might be there that we might want to explore in the future from any Earth contaminants now or in previous missions, we are careful about building our spacecraft and making sure no Earth contaminants go into space with them if they're going to be landing on or entering the atmosphere of one of our other planetary bodies here. Okay, but these missions cannot be done just by the astronauts. It really does take everybody at NASA here. So maybe you don't want to be an astronaut, but you still really want to work for NASA, or you like welding or some other type of trade. Food scientists, flight controllers, launch pad constructions. These launch pads at SLS is huge. And so it takes everybody. It really does take, I'll say, a village to do any of this. That's why it's more and more an international effort here, because it does take everybody. Graphics designers, maybe you really like social media, so you could be some of their social media kind of communicators. Our spacesuit designs, because people need astronauts to be able to move around. The Apollo spacesuits were not really all that conducive to moving comfortably. But then we're going back to the moon and to Mars to study the geology. The rocks are kind of like time capsules. So we will need people who understand the geology to start studying those rocks when we do get those lunar sample returns, or in the future get that return of a rock sample from Mars. And maybe you like to scuba dive, or you've ever been interested in scuba diving. We have the astronaut trainers, because astronauts do train in this big, huge pool, the neutral buoyancy lab, to move in the spacesuits and how they would move with their tools. And they're trained in kind of this gigantic pool that has to-scale examples of spacecraft like the International Space Station. So there's plenty to do, even if you don't want to be an astronaut, or you're not quite sure if that's where you want to go. There's plenty to do to help space exploration here in our future. Okay, let's go back. We have still several questions. I love these questions that are coming, so thank you. Let's see. How will we be combating the CO2 output from the space race? So, and space tourism. And so there are space travel is no longer just a government thing anymore. That's why we have things like SpaceX and some of those other private companies who are working on it. And so that is part of our overall kind of governmental effort, is to reduce the overall impact we have on our environment here at Earth. And it looks like Tad has another view of Jupiter for us.
We are. I figured I'd just give a view of Jupiter since we're back to answer questions again, which is great. I'm going to try to focus it a little bit more. It seems like the clouds are everywhere else that I was going to, every other object that I was trying to get. So we'll go back to Jupiter and try to get a view of its moons. It's very 4 cool Galilean moons. We'll hopefully be able to pick them out already if we bump the exposure up a bit. And All right, I'm slightly losing the ability to talk here. It's very cold out on our observation deck. I hope all of you are inside and are staying warm. If you are outside, well, only spend a few minutes out there if you are.
We do just have a few more minutes left here together, so you don't have to be too much longer out on the roof deck there, Tad. We'll get you into warm up here shortly. But another question that came in as we're adjusting this is, are the trips back and forth to the moon and Mars of pretty much equal duration? Or are there reasons that a trip would take longer going or coming from it? And the biggest factor of what's going to determine how long a space flight takes is where those bodies are in their orbits. So the moon being fairly close to Earth at only about 250,000 miles away, when we launch Artemis, it'll have like a 2-week launch window about every two weeks. So 2-week window where we could launch, 2 weeks where we're not going to, and then 2 weeks where we could, kind of alternating that as we go. But going to Mars, we have a launch window about once every 2 years. And because Earth being closer to the sun actually orbits faster than Mars does as it goes around the sun. And so we want to time it just right so that way we can get to Mars in the shortest duration possible. But once we start that journey, Earth and Mars are going to keep going. And so they're going to be in different places to come back. And so we have to kind of wait for those launch windows for the return trip. So they might not be exactly the same duration, just because the bodies that we're going to and from are moving constantly in space. Okay, I can kind of see some of those stripes on Jupiter there, Tad. I think Tad said earlier that those stripes on Jupiter that we're seeing are some of the winds and the conductive regions. So we don't actually know what's on the inside of Jupiter and how deep some of these storms go into the cloud tops. But much like Earth has weather, so do other planets. And so these stripes and these storms on Jupiter do change. The one that's quite interesting is probably one you've heard of, is the Great Red Spot. It doesn't look like we have that view tonight, but that is a hurricane-like storm that's been going on Jupiter for over 400 years. And so that's a little oddity because some storms come and go, and that one is still going nice and strong, although it might be getting a little bit smaller over the past several decades, but it's still quite large, about 1.5 times the size of Earth itself. And so that's what we can kind of see when it's not so windy out. As we can see the wind shaking the camera and the scope out there.
Every time I think it quieted down, it just picks up again.
Yep. The nature of observing, we are completely dependent on the weather. Yep. So a few last questions that are coming in here as we do reach the last several minutes of our evening tonight. Are the permanent structures feasible on the moon? Will they be a great place to kind of create spaceships due to lower gravity? And how can we make this a possibility? So we do hope to establish bases on the moon, so that way we can be on the surface for longer. I don't know that we'll necessarily build launch pads there, but launching off the moon is definitely easier than launching off of Earth because it is smaller and has less gravity. The kind of way station point might be the orbiting outpost, like Gateway, where we launch something from Earth to go to Gateway, they get resituated, and then go from Gateway potentially on to Mars. So I don't know if somebody was going to Mars, if they'd take the time to actually land on the surface of the moon, or just keep going from outer space, making that orbital spacecraft kind of their connection point. And one of the other questions up here is about our partnerships with Indigenous Astronomy and our collaborations there. We are constantly working on and trying to find ways to expand our ability to bring in other ways of knowing here into our astronomy programs. So in the past, several of our Indigenous programs, working with one of the founders of Native Sky Watchers, Dr. Annette Lee, the summer of 2020. So it's been a little over a year now. The September-October issue of our star map had some Indigenous sky knowledge in there. And then it was that same summer that we did an Indigenous program with her on Facebook Live. So those are some programs that we've done relatively recently. And those can be found on our website and on our Facebook page in those videos. But we are constantly trying to build and support and nurture our relationships with our Indigenous neighbors and our Indigenous community here at the Bell Museum. Yes, so keep your eye open. We do hope that many more will be coming up in our future. It looks like you circled some moons for us, Tad. Did you figure out which moons were which tonight?
You know, I just been sitting here. I've been talking with Mitchell here, and we're trying to figure it out. The various sources we've got, like Sky and Telescope or Stellarium, some different apps we're using. They all say that these moons aren't where they actually are. Our best guess, at least though, is that maybe the smaller one, the smaller circle. I realize these have kind of drifted off a bit here. This one may be Ganymede. This one up here is Europa, possibly. We were talking about Europa a little while ago. Down here, this is where things get a little iffy. That may be Callisto. However, according to all of our sources, Callisto is supposed to be a lot further away. It's almost like at the furthest extent of its orbit. So it's a little confusing as to why that would be Callisto. Because it doesn't seem like it should. It doesn't seem like it's in the right place. Admittedly, all these things could be wrong. Weirder things have happened. Io, for those counting, incidentally, Io is directly in front of the planet. So Io, actually, I wonder. We'll play with the exposure a little bit here. Maybe we might see a transit here. We might get a shadow. Maybe if we sort of really crank down some of these exposures. It was very overexposed right there. Let's take a little bit closer look at Jupiter itself. And you know, feel free to tell your friends, you know, that you definitely are seeing Io there in front of Jupiter. I won't dispute it. I don't think I am, suffice to say, on this side of the screen. Play with this a little bit here. But yeah, but it looks like they were definitely moons. I would say definitely moons of Jupiter. Not 100% sure exactly which ones are which. But Josiah's actually asking, what are the best apps available to use to view space activity? I'll take that from a sort of sky watching perspective. If you are looking to sort of understand what's up in the sky, what you're looking at, my favorite is Stellarium. If you've ever tuned into my monthly Minnesota Night Skies, you've seen me use Stellarium quite a bit. It's a fantastic program. There's an app available for your phone, laptop, computer, what have you. Star Chart is another great one for helping understand what's up in the night sky. Star Walk, I think is the one that I've heard Apple users use a lot, heard good things about. Those would be the ones I'd recommend off the top of my head. NASA also does have its own apps as well, and I believe those would be some good sources maybe to view what's going to happen, like launches. But maybe Sarah, maybe you know some better ones.
I don't actually use any of those apps. I use the planetarium. So during the day, I'm in the planetarium, and then I just remember where that is, what's going on that night. So go outside. So I'm not a good resource for telling you which apps to use because I don't use them. But some last questions that came in is, do you have a favorite star?
Do I have a favorite star? That's a good question. Alberio is one of my favorites by far. That's actually kind of still visible in the sky to the west. It's a beautiful double star system. There is also, and I'm actually just going to look up the name because I can't remember off the top of my head here. I want to say it's T Tauri. There is a beautiful star in our winter sky, sometimes known as the winter Alberio. And yeah, it's given the very memorable name 145G Canis Majoris, also known as H3945. I'm sure we'll all remember that really easily. Yeah, if you look up 145 Canis Majoris, I think you'll find out a little bit more about that. It's a really beautiful double star, similar to Alberio. There's also, I was actually naming another one. It's a star cluster we see in the winter. It's the T Tauri cluster near Canis Majoris, near the larger dog. Not a single star there. It's sort of dominated by one very bright star, but with a beautiful cluster around it. My hope is in the winter months, in the next few months or next few star parties, that we'll be able to get that in view. Although, if I could control the weather and the clouds, boy, I'd be making those promises. Sarah, how about you? What are your favorite stars?
I would have to agree that Alberio is one of my favorite to look at through a telescope because of the dual nature of it. One is blue and one is kind of an orangish golden color. So I love looking at that through a telescope. But coming up here in the winter sky, there's great stars to look at to kind of help you star hop and navigate the winter sky. Betelgeuse in Orion is definitely one that I always look for. Aldebaran in the Eye of Taurus the Bull is another one. That whole winter circle, and I'm sure we'll talk about that next month during our next virtual star party in December about what we can see in our winter skies here. So there's plenty of great winter stars just rising above our eastern horizon as the winter goes on, or as we get into winter, I should say. But with that, the last question that came in is, what will be the next exciting astronomical event that we can see with our naked eye? You know what? I'm not thinking of anything off the top of my head, but let me look into that, and I will come back to you in December of what's coming up in the calendar year of 2022. I just don't remember anything off the top of my head there. But next month, we'll be looking at talking about meteors and meteorites, and then the Gemini meteor shower that is happening in December. So I guess that's one of them you could look at. It's one of the best meteor showers every year. So we'll be talking about that next month. But I do want to say thank you all for joining us this evening. The astronomy programs are made possible by Ruth and John Huss and the generosity of donors like you. Gifts of any size do make a wonderful impact for our ability to bring programs like this to you every single month. So thank you for joining us tonight. We hope we see you all here at the Bell Museum and have a wonderful weekend, everyone. Have a good night.